This is 1.7 part 3. So how do you solve a compound inequality? Well, for a compound inequality, you have three sides. So just like on an equation, whatever you do to one side, you have to do to the other side. Well, for a compound inequality, whatever you do to the middle, you have to do to both of the other sides. So if we wanted to solve this one, we're going to add 1 to all three sides, like that. So that's 0. We get negative 3 less than or equal to x, which is less than 6. Oops, I forgot my 3. There we go. So now to finish solving it, we have to divide all three sides by 3 to make this reduce to 1. Did we divide by a negative? No, this bottom number is not negative. That means we don't have to switch our signs. But if it had been negative, you would switch both of these signs the other direction. So you get negative 1 is less than or equal to x, which is less than 2. So to graph that, we know we start at negative 1 and we go to 2. It says or equal to, so we put a bracket at negative 1. It says less than, so we just put a parenthesis at 2. This tells you what your interval looks like. Bracket, negative 1, comma, 2, parenthesis. What if you have a word? Well, solve each one separately. So we're going to add 9 to both sides. We'll have 3x is less than or equal to 18. Divide by 3. So x is less than 6. How about this side? We subtract 4. Negative x is less than or equal to negative 1. So we divide by negative 1. Since we divide by negative, we flip the sign. Remember, this is an OR. Which one of those is OR? Is it union or intersection? OR means union. So let's think about what this means. X is less than 6 looks something like this, starting at 6. X is greater than 1, greater than or equal to 1, looks something like this. So if we want the union of those two, we want everything in both sets. This continues to go on and on and on forever this way, and this one continues to go on and on forever this way. Well, if they're overlapping and we want everything in both, wouldn't that be the entire number line? Okay, so if that's the case, you would say the solution set is negative infinity to infinity. Yet to graph that, you would literally put a line over the entire number line and put arrows at the ends. So you're saying we want that entire number line. Okay, so let's try another one. This time we have an and. An and means intersection. So let's subtract 2 from both sides. Divide by 3. Since we did not divide by a negative, we don't flip the sign. So over here we're going to add 3. 8 is less than negative 4x, and then divide by negative 4. This time you did divide by a negative, so you do flip the sign. Now you never want to write an inequality with the variable on the right. Always switch it around so that the variable is on the left, and when you turn it around, you flip the whole thing over. X is less than negative 2. So we have x is greater than negative 1 and x is less than negative 2. X is greater than negative 1. Greater than, oops, that's not negative 1. Here we go. X is greater than negative 1. X is less than negative 2. We want the intersection. Do these two sets overlap at all? They don't, right? So you would actually say that the solution set is the empty set. And there is no graph because the solution set is empty.